Hey, what's up everyone? This is your friend Sanjay, and now we are going to understand the block and tackle system of pulleys. Alright, so block and tackle system is a kind of arrangement where you have pulley in two blocks, somewhat like this. So, this is the first block, and this is the second block. Alright, first block is also called as upper block, and the second block is also called as lower block. Okay, so block 1 and block 2 will consist of number of pulleys. Both the blocks would be loaded with pulleys. Now let A be the number of pulley in block 1 and B be the number of pulley in block 2. Alright, so definitely A is always greater than or equal to B. That means the number of pulley in the upper block will always be greater than or equal to the number of pulley in the second block. It will never be less than this one. Okay, now we will be taking both the cases one by one. Okay, so let us have an arrangement of the first case where A is greater than B and second case where A is equals to B. Number of pulley is greater than number of pulley in the second block, and number of pulley in the upper block is equals to number of pulley in the second block. So we will be considering both the case. So as you can see over here, the setup is ready in front of you. For the first case, the number of pulley in upper block is 3, 1, 2, 3, and the number of pulley in lower block is 2. So number of pulley in the upper block is greater than the number of pulley in the lower block. And for the second case, the number of pulley in upper block is 2 and the number of pulley in lower block is also 2. So number of pulley in upper block is same as number of pulley in the lower block. And one thing you have to be very careful while drawing this diagram, you will always start from this point, from the effort end. You will try to encircle it. You will keep on doing it till you reach the final point, that is over here. So for first case, the final point is this one, the hanger of the lower pulley, lower block. Okay, for the second case, you are doing the same thing. You are starting from here, you are encircling it, and you are reaching to the final point, which is the hanger of the upper block of pulley. Okay, so that is the basic difference between both the cases, and each string will have the same tension because same rope is used for the entire procedure. Same over here. All right, now the tension on this string which is lifting the load is going to be equals to 1 2 3 4 5 times T. So I can say L is equals to 5T, and here in this case, here the tension is going to be equals to 4 times T. So why I wrote here 5, why I wrote here 4? That is because the number of pulley in this case was 5 and the number of pulley in this case is 4. So your actual load is going to be equals to number of pulley times the tension on the effort, and here also the actual load is going to be number of pulley times the tension on the effort. Alright, so let us try to find the mechanical advantage and velocity ratio for both the cases. So mechanical advantage is equals to load upon effort, which is phi t upon t, which is phi, and here in this case mechanical advantage is equals to 4t upon t, which is equals to 4. Alright. Now talking about velocity ratio. So just like here, if your tension is T and here the tension is phi T, for velocity ratio it would be reverse of that. Here if the displacement of effort is D and here the displacement of load is DL. So if my DL is D, then D is phi times D. Why phi? Because the number of pulleys is phi. In this case, if my displacement of load is D, so here the displacement of effort would be 4 times D. Why 4 times? Because the number of pulleys is 4. Alright. So velocity ratio is displacement of effort upon displacement of load, which is phi D upon D, which is phi, and here for the second case velocity ratio is 4D by D, which is 4. Okay. So calculating the efficiency, which is going to be mechanical advantage upon velocity ratio times 100, which is phi by phi into 100, that is 100%, and here the efficiency is 4 by 4 times 100, which is also 100%. So for a block and tackle arrangement, the efficiency is 100%. Hope the video is clear to you.